and welcome to LectureLoops. Today we are going to learn about methods in Java. Methods in Java are actually block of code to perform a particular task. Sometimes the program becomes too lengthy. To manage it properly, we divide the program into smaller parts. These smaller parts are easy to manage. Later on, we can combine them to make a single program. This is divide and conquer strategy. This way of making program is known as modular programming. There are various advantages of modular programming. So let's see. Modular programming is simple to understand. We can perform debugging easily. It is easy to find and correct errors in smaller portions. Such programs are easy to maintain and update. Moreover, methods are reusable components. We can code them once and can use it many times. We need not to write the same code again and again. Methods are like black boxes. They receive data, perform the task, return the result. We can easily perform the task without going into the complicated details. Body of the method. Okay. So here you can see that there is access specifier, modifier, return type is mentioned, method name is mentioned, and there are formal parameters. Then there are curly braces, and inside this there is the body of the method where we can write the logic that we want to write. Okay. So first of all, we will see what is access specifier. So we use access specifier to restrict the scope or visibility of a method. Examples are like public, private, protected, default, etc. And for example, if we put public as an access specifier, then the method will be accessible from other methods, even from the methods outside the class. So that is why we make some functions public. Then there is a modifier. Here it is static, and other modifiers are like final. For example, if we put static as a modifier, then the method becomes a class method. That is, we can call it through class rather than calling it through the object. Okay. Then there is return type. A function may return a value also. Okay. So the method can return at most one value, not more than one value. Okay. So we have to specify the data type of that particular return value. If our function is not returning anything, then we have to mention void here. Then comes the method name. Method name must be a valid identifier. So it must follow the rules of naming identifiers, and then we should also try to keep the name meaningful. Okay, so that we can understand that what actually is going on inside that particular method. Then there is parameter list. This parameter list, you can see that it can actually the method can accept some data values also from the calling program. So these are the arguments or the parameters. A parameter list is actually the list of parameters along with their data type. It can be empty also. It is actually optional. Then there comes this body of the method. This body of the method contains some valid Java statements to perform the given task. So this is the complete method definition. Okay. From the function header to this body of the method. And there is also a return statement. Suppose your method is returning anything, returning a value, then it must have this return statement also. Okay. Now we will see what is actually the method prototype. So we will see here what is method prototype and what is method signature. So we have already seen the various components of this method prototype. So there is access specifier, modifier, return type, and method name and parameter list. So this is called method prototype. Okay, or the method declaration. And from here it is method name and parameter list. This is actually the method signature. Okay, it is like that. So basically, what is the purpose of method prototype? So basically the purpose is that it tells about the interface of the method to the compiler. It gives the information such as number, order and type of arguments and return value type, etc. Compiler actually matches this prototype each time a method is accessed. Okay. In a method prototype, access specifier and modifier are optional, but return type, method name is mandatory. Okay, parameter list is also optional. We can also put empty parenthesis. So like I can write void sum and like this. So this is a valid method prototype. It does not contain access specifier, modifier, because these are optional, and it also does not contain the parameter list. It is also optional, but return type is optional. Return type is not optional if your function is not returning anything. Then also you have to write, you have to mention at least void here. Okay, and the method name is also compulsory. And you can also write like float, divide or division, and int a comma float b. Okay, so this is also a valid method prototype. Okay, here we are mentioning or you can make like public. Okay, so I have specified the access specifier but not the modifier. Fine. Now, what is the purpose of method signature in Java? So basically, method signature is a part of method prototype. As you have seen, it contains the method name and the parameter list. As Java supports basically the method overloading, so it differentiates two methods on the basis of their signatures. That is, we can have two methods with the same name within one class, but different numbers or types of arguments. So we can have two methods like, for example, calculate area int r. So it will calculate the area of circle, for example, and then suppose the same name of the method, and now it is like int l comma int b. So suppose it will calculate the area of the rectangle. Okay, so in this way we can have two methods with the same name, but the signature is different because the parameter list is different. Okay. So, and also you must remember that Java does not differentiate on the basis of return type. It differentiates on the basis of parameter list only. Okay. Now we'll see the how to access this method. So first of all, we will see the return statement that is there. So the last statement in the body of the method definition is the return statement, and you can see that it can return a variable, it can return an expression, it can also return a value. Okay. So the data type of this variable, expression or value must match with the return type mentioned in the method definition prototype. The return statement causes a transfer of control from the method body to the calling function. Now we'll see how to access the method or the function call. We can access, or we can say we can call or invoke a method with its name along with the actual parameters. So this is basically the function call. Okay, or we can say the method call. When there is a function call or method call in the program, then control is transferred to the method definition. Then the body of the method is executed and the control is again transferred to the calling function. So as soon as a method call encounters, the control is transferred to the method definition. As you can see here, the control will be transferred here. All the statements will be executed one by one. When this method is completed, then again the control will be transferred to the calling program. Okay, calling function. Now we'll see a coding example. And before that, I would like to mention the difference between formal parameters and actual parameters. Actually, the parameters that we have mentioned in the method definition are called formal parameters, while the parameters that we mentioned in the method call are actually the actual parameters. So the formal parameters receive the value from the calling function, whereas the actual values are passed to the called method. So actual arguments contains the actual values. Okay. So this is the basic difference between formal parameters and actual parameters. So let's make a program using methods. So first of all, I'm going to define a method. So public static and int calculate area. So here we are going to calculate the area of rectangle. So we need two variables only, int length and breadth. So I'm taking int L and int B. These are our formal parameters. Now we are going to write the statements in the body, inside the body of the method. So here what we have to do, we have to take a variable like this, int area, and area is equal to actually length into breadth. So we'll simply write L into B, and then since our function is returning this value, so we'll write return area, and that's it. So that is the method definition. Now we'll call this function through main. So we will write the main function also. So public static void main, and it is okay. So here we have to take input of length and breadth, or we can assign the values also. So I am taking the input from the user. So we have to take this scanner class, and it will be like, right, so system dot in. Okay, so we'll take input using sc is our object, and now we will declare two variables, int length that is equal to sc dot next int, like this. And before that we can write a statement like enter the length. Okay, system dot out dot println, and I will write enter the length of rectangle, fine, and semicolon. So I'm just going to copy these lines, and it will become like this. Only I have to change here. So I will write, okay, and yes. So enter the length of the rectangle, enter the breadth of the rectangle. So length and breadth are two variables where we are going to take these values, and now we will call this function, okay, calculate area. And since this function is returning an integer value, so we must have an integer variable to receive that value. Okay, so then we will call this function calculate area, and here we will supply length comma breadth. Okay, actual values will be transferred. The value of length will be received by this L, and the value of breadth will be received by this variable B. Okay, now we will print the result, and the area of rectangle is, okay, and it is the variable A. Okay, so in this way our program is ready. So let's run this program. Enter the length of rectangle. Suppose I enter it as 12. Enter the breadth. Suppose it is 4. Then the area is 48. The area of rectangle is 48. So in this way our program is working fine, perfectly correct. So what is happening here actually? So we are taking input in these variables, and then we are just calling this method. As soon as this method call encounters, the control will be transferred in the method definition. Here the value of length will be transferred to L. So the value of L will become 12, and the value of B will become 4. Now in this method body we are calculating the area. So 12 will be multiplied by 4, and the result will be 48. So it will be, get stored inside this variable area, and then return area means this return 48. So this program, this function, this method call area will return the value 48. This and after this return statement, the control will again be transferred to the calling method, and here the function call will be replaced by 48, and this 48 will be assigned to a, and in this way we get the result in our main function or in our calling function. Okay, these L, B and area, all these are local variables, means we cannot access them outside this method. Okay, we can access them only inside this block. So that is all about the method. If you like my video, please share, subscribe to my channel, and please press the like button also. Thank you very much.